Welcome to the SCSA's video toolbox series. Today, we're talking about pinch points, rotating equipment, basically kind of getting trapped, and amputations, deaths, things like this happen. And let's talk about this. So the industrialization of our daily tasks causes frequent interaction between people and machinery. One major risk of this interaction is pinch point hazards. In some cases, pinch points can lead to amputation or death. An injury like this is irreversible and oftentimes difficult to mentally cope with. My brother, he chopped off the tip of a finger. I think it was his pinky finger, but it was on his right hand. Every time he shook hands, he was self-conscious. He said for a year or two about having just the tip of his finger nipped off. It mentally affected his well-being. So pinch point risks. A pinch point is when two or more objects come together and create an area where body parts or loose clothing can get caught. Pinch points are typically one of two types: press or rotative. A press type pinch point occurs when two parts come together in contact with each other. The risk associated with this type of potential to have a body part get caught and grinded in the machine. Press type pinch points can also cut or lacerate your body, but the most common injury is amputation. What about rotative? Pinch points occur when motorized machines have components that rotate opposite of each other. The risk is present between the rotating pieces and typically at 45 degrees. Some materials, such as rubber, increases the risk of being caught in the pinch point. I want to talk about a couple other rotating machines later on. I got a couple examples in the shop here that we're going to go through some of the actual hazards that present themselves, such as this one, and then also some of the corrective actions that I've implemented on a personal basis. Okay, collective protection. There's an exhaustive list of collective protection equipment or protective equipment that aids in preventing injuries and incidents. Machine guarding is a form of collective protection that safeguards machines. This includes guardrails, safety shields, safety switches, and more. When working with machines where safeguarding is in a fixed position, it is important to maintain the guarding in a proper place in order to provide adequate protection. If the guarding is of a removable form, stop the machine, perform a lockout, tag out on that machine so it cannot be restarted while we're working on it, no matter what. Not just turning a switch off, not just putting a sign off, lock out, tag out. Other equipment such as PPE exists to keep you safe when you work with these machines or in these scenarios. Remember that in order for PPE to protect you, you must wear it properly and as needed. Pinch points and material jams. This is going to do with a lot of machines that you can have a jamming situation going on, but what we have energy that's waiting to be released. So sometimes a jam occurs in a pinch point area. In this case, we face two risks: an energy concentration at the pinch point and a sudden release of that energy. When a jam occurs at a pinch point, the material can generate a concentration of energy. When the jam is removed, the equipment can restart without warning and catch you in the pinch point. You could always use a tool and not your hands to unjam a process. When a jam is removed, there's a sudden release of energy, which generates a potential falling risk. To prevent this kind of incident, make a risk analysis of the situation and favor a mechanical solution over a manual one. If that's not possible, make sure to position yourself in a strong supported posture to prevent any falls. So basically, we're using our body or our hands or whatever to release a jam, and when that jam releases, it's instant, and we can actually fall into, or whatever the configuration is, into a position where we then could be caught in between something or in a rotating part. Okay, dress appropriately for the machine. This is something, I'm a journeyman welder. I've seen this through my career. I've seen it with lots of people, machinists. I've seen with people in construction zones. A lot of people work in machines. Anything that rotates, dress appropriately. We discussed the potential for bodily injury when a limb or appendage comes in contact with a pinch point, but other elements can also put you at risk of injury. So clothes and jewelry can easily get caught in a machine. This situation poses serious risk as clothes and jewelry may not tear and can drag your body towards the pinch point. Make sure clothing is fitted well. Remove any loose articles such as scarves, dangling bracelets, lanyards. It could be loose fitting coveralls, that kind of stuff. Get rid of that stuff before starting the task. Hair is similar to loose clothing and jewelry. When hair is caught in a pinch point, there's a large potential for serious injury. Always secure hair before beginning a task. If your facility or construction site, it could be tearing down trees, using a tree shredder, all kinds of pinch point potentials, rotating machinery. If they have a loose clothing, jewelry, or hair policy, please follow it. It's to keep you safe, and no policy. If no policy exists, follow the above advice to secure or remove loose elements before working. Okay, perfect tool. There's one perfect tool in all industries, in all workplaces, and it is our hands. A major risk associated with pinch points is getting caught and injured. This most commonly happens at the hand, but is easily prevented by always using protective equipment like gloves when working with the machine. Paying attention to machine guarding and ensuring it is working properly. Staying aware of pinch points that generate power outside the process, such as reverse modes or residual energy. Using tools if working near a pinch point or fixing a jammed machine, and not wearing loose clothing or jewelry and securing your hair. Our hands are the perfect tools. They are not replaceable with any other tool. I guess I've heard of some people getting a digit replaced with maybe a toe or something like that. I'm sure that's not a very fun process. Accidents to the hands have potential to cause serious injury and even permanent disabilities. So at work, I would recommend we identify all potential pinch points. Now, either we identify them prior to conducting the job or during the process where we're in the middle of a hazard assessment process and we're foreseeing what our job looks like maybe we're lifting an air conditioning unit onto a roof and there's going to be workers on the roof to receive this using a crane. Now, are we going up against another object on the roof where there's a potential pinch point? We got to look at these processes ahead of time and come up with a plan so no worker gets involved in a pinch point scenario without thinking about it. Sometimes we're so focused on what's in front of us that we don't think about, what could actually happen in an event of the wrong move, a swing of the crane, whatever it is. If we're in the line and something goes wrong, we were in the wrong position. So identify all of them and then get some controls in place, whether it's practices, procedures, whether it's on your hazard assessment, just looking at the specific task and communicate this control or these accumulation of controls to everyone involved, from the crane operator to the tagline user to the person that's directing the crane in a scenario like that, to having placards put on machines that indicate prominent pinch point things, to safeties that are put onto machines and controls put in place that way. High vis vests, different PPE that we can use in any given scenario. Lockout, tagout procedures for different equipment, so we know that workers aren't going to get involved in something without using proper lockout procedures. And even reverse parking and honking. A lot of places say, look, we reverse park, we honk before we back up. And a lot of this is for one, they don't get pinched under a wheel or something. But another one is that whole idea of the pinch point of a worker between two objects or between two vehicles, stuff like that. So now I want to go through a few scenarios that I have just alone in this little shop of mine. Here's one. Now I get this is a bucket. Look, it's very light. Not the point. I'm going to set this bucket down like it's a heavy motor. I've set many motors in place in the past, and a lot of times you're in this exact scenario. Anytime you're using a lifting or hoisting mechanism and you're doing something, it's typically something heavy, and we have to maneuver that piece around and get it set into place. So we're either guiding it, we're doing it ourselves, someone else is running the controls, whatever the scenario is, we got to think, where am I? Where's my hands? What kind of pinch point do I have? Now, if I get under here with my knee, and this thing's full of concrete, it weighs, let's say, who knows? Let's say this is a motor that weighs 300 pounds, 200 pounds. If this drops from 4 inches and that sling breaks, or there's a failure of the crane, or a chain link breaks, or whatever it is, this hoist that I'm using, something slips and it falls, even 4 inches can do some permanent damage to, and that is essentially a pinch point right between two objects. This is falling. We want to stay. I want to stay from underneath all loads at all times. Never leave a suspended load without being, alone for a coffee break or anything like that, because potentially there's something that goes underneath, and scenarios change. Now, another thing is, this is very important, and a lot of people know this already, but don't stick your hands anywhere that you wouldn't stick the most valuable piece of your body, maybe your head or something like that. Because if I start going like this and I'm maneuvering this thing because I think I trust the crane, I trust the slings, I trust the operator, and I start doing stuff like this could easily get dropped onto my fingers, and now my fingers are trapped in there with 100% of that weight coming down, and it literally can result in amputation of my fingers. So what I want to do is then use taglines, use things like that when you're setting steel in place. Obviously, get it in a position that you can do it and lower it down, stay out of the line of fire. Now, I want you to come over here with me. Drill presses, obviously, are something. Now, a couple of common things that I have in this shop. I use hammers all the time. So I got a hammer here. Obviously, pinch point would be hammer between two, a rock in a hard place kind of thing. And you're hammering. Simple. That's a very easy thing to understand. Now, I did talk to a worker before using an impact. I had no idea that this could even happen. Using an impact under a semi-trailer, taking off some seized bolt, probably I think they might have had a 1/2 inch or a 3/4 inch impact like this. Heavy duty machine. This thing has about 1,000 foot-pounds of release torque on it, 1,200 even. And he got in there, and I seen he had an amputated finger. Hey, and I asked him. I always ask because I want to learn from what happened, stuff like that. A lot of people aren't born just missing digits. It happens, and a lot of times that happens doing work-related activities. So he's underneath the trailer taking this thing off, and it actually rotated and it caught his finger, his finger or fingers in the rotation, and he amputated as a result. So where's your hand placement? What are we doing? It's so important. On that note, I have one of these. This is a right angle drill. It is non-forgiving. Okay, like this, they make them now. I think they make the new version of this model with a limited slip in its side of it. So that slip is designed when this binds, this hole saw binds or whatever I have in here. If it binds, it'll actually slip and it won't crush my hand. Now, if I get into a position using this, and this comes down to equipment training in a workplace, if I'm going to use something like this and I'm going to have it out for workers, and I have, we're going to be drilling plumbing in the joist cavity, or drilling out for electrical throughs on the joist cavity, and I get a hole saw up in there and it binds and I'm out of position and stuff like that, my hand can easily get caught. And that's the scariest part of this machine, is me not holding onto it properly, maybe not using the handle properly, and that it gets caught and binds, and it actually gets me between a rock and a hard place with my hand or something like that, and it binds. Some people even get their heads caught and it smokes them. A lot of dangers with something like this, and it's just a matter of knowing how to use it and using it properly and keeping yourself out of the line of fire. So that's a good one. Drill press, another great example. Especially you can get jams with the drill press. Sometimes you'll have your vise on the drill press. It's locked down and it's belt driven, so you'll be drilling through something. It jams. I'm telling you. You get in there too tight with your clothing or something like that and unjam it, get the jam loose, and sometimes it'll grab you and it could actually spin you around that spindle, or spin your clothing in and drag your hand in before something rips or something starts slipping again, so you can turn that machine off. So very important. And then the last I want to show you is I have an air compressor in this room behind me. And let's just take a little walk. Hopefully no one gets dizzy. Okay, so no lights. In here, I have a drill press. I have a air compressor, and the air compressor has pulley systems on it, and it has a machine guard affixed to it. And there's a way to get in here and that, but I need to make sure um, that this is hardwired in, and that so it's on a switch and stuff like that. This, if I go in here to work on this, maybe I need to set this motor, or maybe I have to tighten the belt, whatever it is, maintenance. Um, I would never leave this guard off. Once I take it off, yeah, is it easier to get to it? If I ever need to switch the belt again, if I leave it off, for sure it is. Does it present a pinch point or a rotational hazard every single time that I'm in the room at that point? Yes. If the guard's not there, it presents that. So with this, um, I would actually go to the breaker and turn the breaker off, not just the switch, not just whatever. It's an actual lockout procedure for getting in here. Okay, so in the end, to end this, I'd like just to say, you know what? This is where amputations happen. A lot of deaths happen in this way as well. Uh, assess your situation, assess your workplace, and uh, we can go home at the end of the day with as many digits as we went to work with. Thank you.